Hello guys, welcome to my new video. So in this video I'm going to speak about a DIY power supply. I wanted it to power my projects as I can't all the time use DC batteries all the time, as it would get drained out very fast. So I found this DIY kit in Amazon for a price of 1812, and I bought this. You will get a PCB like this and components. You'll get the soldering video of this a board which I made. Yeah, I hope you can see it properly. So this is my board. So in this kit only one problem I found mainly three problems which I got, where in this PCB I didn't get this heat sink, which was very much needed for this this transistor. I took it from an old TV stabilizer, not stabilizer, a setup box. I took it from a setup box. This was used to cool the processor inside this heatsink. So I'm using this for now. And the other thing was that for the fan, there's a option to plug in your fan ports here, and here it is marked 24 volt for the fan, but the transistor I received was damaged, so I just removed it, and I didn't have the 24 volt regulator transistor, so I am using a 9 volt regulator. It is 7809 transistor, so here I would get 9 volt. Okay, then one more thing is that this there was an 82 ohm resistor over here, but while testing that was getting very hot, so I just changed it with this is a 100 ohm 1 watt resistor, so 2 in parallel makes 50 ohm resistor, so I just replaced that one. And one more thing was that here this 56 kilo ohm resistor, I didn't receive that, so I had to use a 46 and a 10k. It's not a 46, it's a 44, I think. I don't remember correctly. I think it's 44 and 10, so I had to do it like this. So this is my circuit, and I replaced the terminals over here. They had given terminals like, I'll show you the image. These were the terminals. This 2 leg 1 and 3 pin connect screw terminals I just removed, and instead of that I just soldered 2 wire. So this is the input, which is 24 volt AC, and here is the regulated output. So for inputting the 24 volt AC, I am using a transformer. This is a 12012 transformer, and 5 amp is its rating. You can see it's 5 amp and 12012. And the main thing of 12012 is that there would be 3 terminals. So if we consider the middle terminal as the 0 volt terminal, then we would get positive. We can't say positive. You would get 12 volt from this side and 12 volt from this side. So instead of taking the center tap, I just took the 2 sides. So these 2 sides, and it would be added to 12 plus 12, 24 volt AC. So this is my input, and the main input of the transformer goes to AC voltage coming from our power lines, which is 220 volt. Then And one more thing I did, sorry, the camera, is that here the terminals for current and voltage regulators were given here. So this would be plugged in like this, but they gave the regulators like this one. Here you can see this is the regulators they provided, but I didn't like that because I don't have the knob for this potentiometer. Look, it can't get in, so I just swapped it with the other one, but the same value. This is 10 kilo ohm and this is also 10 kilo ohm. It's written here 10 kilo ohm. Okay, so these are the main changes I made. So it's a working piece and I'm very happy with this, but the only problem I found other than this, the others I told, where its rating is 1 to 30 volt DC output, but I only got from 1 to 25 volt. I don't know why I got 5 volt less, but the 3 amp rating for this is correct. I got up to 3.4 amps. That's a good sign. And most of the parts remain cool all the time except for this resistor. This would get heated up very fast. That's the only problem I faced here. And if you are loading up a bigger device, then you should have a fan for this. This diode, not diode, it's a this transistor would get heated up very fast. Okay, so I made a case for this. So I'll show you the case. This is the case which I made. So you must be remembering this case from my thermolysis device video. Look, this is a beauty shape thermolysis device. I just took out every board and the transformer out of this, and I just drilled holes over here. This is the holes for the transformer, and I just replaced. This was the front part of the device, but I am swapping it as the back part. So I'll tell you the main plan. So the main input voltage from the plug, I'll show you the cable. So this is the plug going to the main AC 220 volt. So the cable is coming from here. This cable would go in through this last port over here. This would go in through here. Then there would be a fuse over here. Then this hole is just left free just for an air gap, and I am using this as the main switch. Okay, then the transformer goes in here. So transformer is like this, and I'm using the screw to tighten it. So transformer goes here and the board goes in this side like this. So this is my plan. Not like this. I may keep it like this or this. Anyway, I'm planning to keep it like this, as the main input cables are on this side, so it would be easier to solder this here. Then I was planning to keep drill some holes in the side. I'll just move this transformer. I was planning to drill some holes in this side and place a fan over there, DC fan, but I don't have it currently. After getting the fan, I'll make a small short video on that too. That's okay. Then the back part of the real machine, I turned it into the front part. So hope you can see this. I just drilled a hole. Oh, sorry. It's not like this. Look, this is the front part. I'll just move this body from here. So this is my voltmeter. It also can measure ampere also. So I'll just keep it like this. And the cable. I haven't soldered anything. I'll show you the full circuit diagram later. So it will go in like this here. Then one LED would be placed here. Then the potentiometer knobs here, and the output terminals over here. So I'm going to fix the whole setup now. Let's start with the transformer. It's the most hardest part. So guys, my power supply is ready. That's my circuit with the amp from 0 to 3.6 amp. These are the output terminals, an LED indicator, the voltmeter and the ammeter, the voltage regulator. It's written here. So the knob, this also has a knob. Sorry, the table is vibrating. So this is my circuit. It's completely finished, but here I have done a change in the circuit, which is that the transistor I had was, let me try to focus it. Sorry, it is D1047, but while experimenting, this transistor got burned off and now it's not working. So as this was an NPN power transistor, I swapped it for another transistor, which is C5200. I just swapped that. So this is the larger transistor which is kept here, this one. And one more thing, I added a heat sink for the 9 volt regulator, which was 709. These are the main changes I made in the circuit. Then this is the main input part. So the AC mains comes in from here. Then the live wire goes through the fuse and then to this switch. So I'll show you the back part. So this is the back part. So here's a fuse. I'll show you. You should always add a fuse to your circuit. It's a very compulsory part. There's a fuse. Just keep it in back. Sorry, the table is shaking. Okay, so the main wire comes in this part, comes through this hole. This is a free hole. I haven't kept anything over here. After that, the switch, main on off switch. This switch also has a light indicator. I'll on the main switch. So look, this also has a light indicator in that. So this is the main part. And always don't forget to ground your body. Ground the body of this metal. I have done it over here. Wait, I'll show you. Just move the lighting. Did you see that green wire which is connected to the case? That is the ground wire. So that's the ground wire. This one. Green is the ground wire. Then into the transformer, which then comes out as 24 volt AC through these 2 points. Then goes into the circuit. Then rest all parts are same. And one more thing, I removed that small LED which was over in this part. Don't have that LED here. Yeah, this was the LED. Oh shit, just fell in. Sorry. So I can't. Oh, this was the LED which I just kept here. I just unsoldered it, and in its place I soldered a bigger one and also an LED holder for that. So this is the LED. It shows the current limiting factor, and one of the main things I have to say about the circuit is that you should all that if you are using a metal case, mainly in the metal case, the first thing is that you should all the time ground your metal case, and secondly keep your board a little bit higher than the plate. I'll show you, because that's a very important thing, otherwise you can short out your circuit. So I'll show you. Look, I have kept this board a little bit higher than the ground. Wait, this lighting, sorry, I hope you can see that gap. I have used spacers to keep that at a height. There's a gap here. So I'll just keep this back. And the ammeter has readings from 0.5, 1 amp, 1.5 to 2.53, 3.5 and 6, 3.6. These many are the readings. Very hard to keep. Okay. So, and I also marked a white part over here using a whitener. Look. Kept it back. And one more thing, I added a plastic sheet over here. This is a plastic sheet I added here just to insulate the metal body of this case from the circuit, means output and the ammeter and this LED. Yeah, I didn't want this to get short, that's why. And just for a small stability, as the ammeter was very loose before, this was very shaky, but now due to that plastic sheet it's staying okay. So this is my circuit, and I'm just going to close this thing. And one more thing, if your transistor D1047 burns out by any chance, then you can use other transistors like the one first I showed you, which was C5200, or you could also use 2N3055 transistor. And there's one more one, I forgot its name. I'll put the link in my description of the video. You can buy all the things from Amazon, and I'll put the link for this, except for this metal case, as I got it from the junkyard. And I'll put the wiring. If you want to know about the wiring system of the ammeter or anything, you could just ask me in the description. I'll give you a link to you. So I'll just close the case. Oh sorry, the case is gone.